Problem number 714. Best time to buy and sell stock with transaction fee. You are given an array of prices, where prices I is the price of a given stock on the ith day, and an integer fee, representing a transaction fee. Find the maximum profit you can achieve. You may complete as many transactions as you like, but you need to pay the transaction fee for each transaction. You may not engage in multiple transactions simultaneously. Okay, so you must sell the stock before you buy again. So I think it means you can only hold one stock at a time, and the transaction fee is only charged once for each stock purchase and sell. Okay, so for when you buy a stock, you should add a fee, and when you sell a stock, you should add a fee as well. So okay, we'll check if prices list can be empty. Okay, it cannot, and okay, the fee will be 0 to okay. So you will not have negative values, so you can have like 1 like this. Then the maximum profit, if you don't do anything, it will be 0. And if you buy, like if fee is 2, then yeah, then can we have negative profit? But yeah, you can don't do anything. Yeah, so then it will be 0. Okay. So we can look at the last day, and there are 3 options that we can do. We can buy the stock, and if we buy, then the profit will be is the previous profit from day 0 to day I minus 1 by, and then so we have to minus price I. And if we sell the stock, the profit will be the previous profit from day 0 to day I minus 1 plus the price today. So the problem shrinks, and it's keep repeating the same thing. So we can use dynamic programming to solve the problem. And there's another option, is that if we do nothing, we can do nothing, then the profit will be the previous profit. And it's the same from day 0 to day I plus 1. We have transaction fee forgot. So for buying, you have to minus price I and minus fee as well. And for selling, you should also minus the fee. And when we do nothing, we don't have to add or minus the fee. So yeah, and for buying, we have to hold a stock when we buy, and for selling, we have to hold 0 stock when we sell. When we buy, we have to hold 0 stock when we buy, and for selling, we have to hold 1 stock to sell. So divide the profit. So we will have with previous holding 0 stock, and this will be holding 1 stock. So then, since we are doing dynamic programming and it is repeating the same thing, I would like to first use recursion. So for recursion, and I want to go for depth first search. So I will first define depth first search and have the parameter I to represent the I state. And with holding the number of stock. So H will be only 0 and 1. So the definition of DFSIH will be the maximum profit from day 0 to day I with holding 0 or 1 stock. And we can discuss separately for H0 and H1. So this will be so for 0, with holding 0 stock now, it will be to calculate the maximum profit from day 0 to day I with holding 0 stock. It will be it has two situations. First one, we can do nothing in the previous day, and today we do not. Today we do nothing. So that is the profit comes from the previous day. So it will be DFS. Previous day will be I minus 1. Day 0 to day I minus 1. And holding 0 stock. Because in the previous day we hold 0 stock, and today we do nothing, then we will have now holding 0 stock. And the other option is that in the previous day I have 1 stock, and then I sell it now today. So I sell, I will get the price I with the I'll get the price I, and I'll have to deduct the transaction fee. So it will be like this. And if currently I hold 1 stock, then it will be in the previous day, it will have, today I will do nothing. Then it must be in the previous day I have hold 1 stock. And if today I have to do something, and that will be buying 1 stock, so that I have 1 stock now. So in the previous day I will have 0 stock. Then for buying, I have to deduct the price today and also minus the fee. Okay, that is the function. So for the time complexity, it will be O(n). Yeah, since the parameter H only has two situations, and for I there are day 0 to day I. For I there are n days. So the time complexity will be big O(n). And we'll start with we'll define n as the length of price, and we'll have DFS I with H, then it will return the maximum profit. And with the boundaries, I'll have Yeah, because since day 0, we have an option to buy a stock to do this. So I would prefer, or yeah, we can do nothing. So I would prefer having boundaries with I smaller than 0. And when I smaller than 0, the only thing like the maximum profit will be 0. Yeah, but there is something that we should notice is that when I is smaller than 0, we cannot hold any stock. So if H is 0, then we can return 0, else it is invalid. And for invalid, we will give it in negative infinity, so that when it is in like this, if I is 0, then this will be DFS -1 with holding 1 stock, and that is invalid. So we cannot count this. We should have the function counting this. So yeah, we will have it for negative infinity, so that the function will ignore this option. Then we will have the thing, yeah, when we are outside the boundary, we will, yeah, so if H is 0, then we will return the maximum between DFS I minus 1 with previously holding 0 stock, and DFS I minus 1 with previously holding 1 stock but sell that stock today, and we will have the fee. Else, if H is 1, then we will return the maximum between DFS I minus 1 with previously holding 1 stock and previously holding 0 stock, but buy 1 stock today. And we have to have the fee. So that's it, and we will return DFS and -1 with H. Yeah, we should do max between 1 and 0, but for this, I think it would be always, not really, because we have fee. Then maybe we can keep this. Yeah, because like in the previous questions, without having fee, holding 1 stock is holding 1 stock in the last day is definitely not going to get the max profit. So yeah, we will leave this, and yeah, let's see. Oh, prices, my bad, typos. Is there any other thing? No. Okay. Oh. Oh, it said it only charged once, not at each purchase. Okay, so I misunderstood. Okay, then I think we will do it at selling. Since you should do like a complete transaction, then we will have to, then we'll charge a fee. So we will do it like this. This is selling from 1 to 0. Okay. Correct, and let's add a catch. Since there are many repeat completion calculations. Okay, then I want to know if these two, like, we can remove this one. Let's see. Oh, we can. Okay, well, I think I would change the advanced recursion method into for loops. So for loops, I will have a matrix called maximum profit to keep track of every maximum profit at each day range. So like I will have first I will have the I think I will have negative inf and I'll have 2 for the age. There are two situation, and then I will have the eyes. So for in range n plus 1. Then the default value, like we have to add these boundaries, like when I is 0 and we have a dummy node, so we will have n plus 1. So for a dummy node, that is I is at index 0. I is 0. So h is 0, then we'll have 0. Else others are negative infinity. Yeah. Okay, we can start our for loops. For I in range n, maximum profit I, and when h is 0, we'll have max profit I. Oh, sorry. Since we have a dummy node, we will have I plus 1. Then this will be I, because before it is I minus 1. And we'll have 0 for h. And maximum profit for the previous day is I, and h is 1 plus the price today and minus the b, that is selling. Then for maximum profit, I plus 1, when h is 1, we'll have, oh sorry, copy, this is 1, and we'll have buying, so we will have 0, h holding 0 stocks before, and buying will be minus, and without fee. Okay, then at the end we will return the maximum profit at n and 0. Okay. Okay, we can still so for now the space complexity is n, yeah, like 2 multiplied by n. And we can definitely optimize the space since it is only like it depends only on the previous value. Yeah, so we can change it like yeah, we can have maybe like profit 0 for this and profit 1 for this. So for 0 we'll have 0, this default value, and for 1 we'll have infinity, negative infinity. Okay, so let's change it. This will be profit 0, and profit 1. Oh, and because if we change this to profit 0, then this profit 0 will be a new is this one. So it is not allowed. So the best way we can do is like maybe like this. Okay. Then we will have profit 0 for the answer. Oh, let's see. Okay, well done.